Good evening, everyone.
Good evening, ma'am.
Good evening. How are you all? All good?
Yes, ma'am.
Okay, then. So today we will be having week 3 and week 4 revision session. So, yeah. So the main thing is we will be doing is I will be briefing about the week 3 and week 4. Then we will be doing some questions. Fine?
Yes, ma'am.
Okay. Shall we start or should I wait for more people to join? Okay, let's start then. Okay. So in week 3, what all we learned? The first thing is week 3 is all about the PMF, right? The discrete random variable, correct? It's all about discrete random variable. So in week 3, the first thing that we learned is about the expectation. What is expectation? What is expectation?
Expectation is going to
Expectation is
summation of I
basically
into f of xi.
Yeah. Expectation is actually summation of x into probability of x, right? Basically, it is the average, you can say, or the mean. Fine. So what is x and what is px? If suppose if x is given, the some values is given like x1, x2, x3, and probabilities are given associated with it. This is p1, p2, and p3. Then how do you calculate the expectation? Expectation will be calculated as x1 into p1 plus x2 into p2 plus x3 into p3 and so on. So like this we calculate the expectation. Fine.
Yes, ma'am.
Okay. Now, okay. So the next thing is we have um let's suppose like okay, let's suppose my x is following my um let's suppose my x1, x2, x3 and so on. I have x in random variables. They're having a joint PMF. Okay. Joint PMF, and the range is the whole tx. Okay, now let's suppose I am having a function y, which is the function of all the values of x. Okay, now for this, if I have to find out the expectation of y, it is basically what? Summation of
g of x into the probability of x.
into the or you can say the PMF of x. Okay, so let's take an example. Let's suppose my x is following some values. Um, let's suppose 0 and 1. Okay, so this, the probability of getting this is like 1 by 2, and the probability of getting this is 1 by 2. Now let's suppose there is another function g of x, which is basically what? X square. Okay, this is x square. Now I need to find out the expectation of gx. How will I find out? There are two methods, right? So first of all, I will be finding out the values of x square. So x square, what are the values that x can take?
0 and 1 again.
0 and 1 again, and with the probabilities 1 by 2 and 1 by 2. Okay, so now the expectation of gx x square will be as 0 into 1 by 2 plus 1 into 1 by 2. And the next method is, how can I do it? Basically, I will be squaring all these values. 0 square into 1 by 2 plus 1 square into 1 by 2. In this way also, I can calculate the expectation, correct?
Yes, ma'am.
Yes, ma'am.
Yes or no?
Yes, ma'am.
It's fine? Okay. Now, next thing is we have what else we had? Okay. Then we had the variance, right? What is variance? Variance of x?
Expectation of x square minus expectation of x whole square.
Okay.
Expectation of x square minus expectation of x whole square. This is my variance. Okay. And what is my standard deviation? It is under root of
Under
Root of
variance
variance.
variance of x. What basically what my variance tells us?
Deviation from mean
Spread
value.
of the data set. The spread.
How much the
The
spread
spread
of
of
the data
variables.
is?
Spread, or you can say Then we have the properties, right? What are the properties? Okay, we know that if expectation of two random variables, the sum of two random variable will be equal to their individual expectation,
Yeah.
sum of their individual expectation. Now let's suppose I am saying that x and y are independent. Okay, then the first thing is expectation of x into y will be equal to
Expectation of x into expectation of y.
expectation of x into expectation of y. And the second thing is variance of x plus y will be
Variance
equal
of
to,
x plus y is equal to variance of x plus variance of x.
yeah. So these are the two important things that we learned in if my x and y are independent. So the first thing is the expectation of x into y will be equal to expectation of x into expectation of y, and variance of x plus y will be equal to variance of x plus variance of y. Fine?
Yeah.
Yes, ma'am.
Okay. Yeah. And there is okay. So there are some distributions and their expectations, right? So for the binomial case, what is my expected value?
NP.
NP.
NP, and variance will be
N1 minus
And
P.
1 minus
Into
p
1
times
minus.
p.
yeah NP NPQ, or you can say NP1 minus Q.
The
Then
place
we
of q
have,
is equal to 1 minus q.
yeah, correct. Then we have uniform. What is the expected value
N plus 1 by 2.
Said n plus 1 by 2.
for uniform? N plus 1
Yes, ma'am. By 2.
by 2. Okay, then what else? We have Poisson distribution.
Lambda.
The expectation and the
Lambda is
variance, both of them are equal to lambda.
Lambda.
Correct?
lambda.
Yeah. And then, yeah, that's it. Binomial, uniform, Poisson. Any other distribution?
Geometric.
We have
Geometric.
geometric as well.
Bernoulli.
What is the geometric expectation of geometric distribution? 1 by p, and
Yes,
variance
ma'am.
of x will be equal to 1 by p
1
upon
minus p by
p
p.
whole square.
P square.
Okay. What is the for the Bernoulli case? The
P.
expectation
Is it P?
P.
p
P.
and variance
1
P into 1 minus
1 by P.
p into 1 minus p.
yeah p into 1 by p, or you can
1
say
minus
p by p into q. Okay. Now the second thing is we have standardized random variable. What is that?
Ma'am, what is variance in Bernoulli? Can you please again tell?
Variance is p into q, or you can say p into 1 minus p.
Standardized random variable is where the expected value is 0 and variance is equal to 1.
Correct. So standardized random variable is basically in which my random variable is having expectation 0 and variance as 1. So if I have to convert a random variable x into a standardized, what I will do it?
X minus mean by standard deviation.
Which is sigma. So I will be converting it by subtracting that random variable with the mean and dividing it by the standard deviation. Fine.
Could you explain what is the use case of this conversion? What kind of problems that we will be dealing with to standardize the random variable?
Basically, standardized random variable in the sense if we are dealing with normal distribution or something, right? So if we are calculating anything, if we are calculating according to the normal distribution, is really difficult to solve any equation or any problem or something. So that's why what we do is we convert into a standard variable. Okay. So if we have a standard variable, we have a standard table as well for that. Okay, so that is why it makes us easy to solve any questions.
Okay.
Okay, then the next thing is we have the covariance. Covariance between x and y will be equal to? What is the covariance?
E of
value of
x,
y
xy minus
minus
E of x
expected value
into
of x times
Expectation of
expected value
x
of y.
into expectation of y.
Yeah. So covariance is expectation of xy minus expectation of x into expectation of y. Okay. So basically, if my covariance, let's suppose my covariance is positive, then if my x is increasing, then y is
Increasing.
y is also increasing. Let's suppose it's negative, then
They are in the opposite directions.
yeah. So if my x is
Inverse.
decreasing, my y will be increasing, or you can say if my x is increasing, my y will be decreasing. Correct? Okay.
Yeah.
And then one more thing is, let's suppose my x and y are independent. Okay. Then what is the covariance?
0.
Covariance is 0. Why?
Zero.
Because we know that covariance is expectation of xy minus expectation of x into expectation of y. Now this can be written as expectation of x into expectation of y, and this will get cancelled. So in short, we will get 0 as the covariance. Correct? Fine.
Yes, ma'am.
Yes.
So now I am asking, let's suppose I say that my covariance is getting is my 0. Okay. So can I say that they are independent?
No.
Always? No, right?
No,
So
No.
it
ma'am.
can be dependent. There can be cases in which my covariance is coming out to be 0, but they are independent. Sorry, dependent. Okay. But it is always true that if my x and y are independent, I will always have my covariance as 0. Fine. Okay.
Yes, ma'am.
Then, yeah. Then the next thing is we have the correlation. What is correlation? Correlation is defined by rho, which is equal to
Covariance of x,
y
y by
standard
standard
deviation
deviation
of
of x
x
into
into
standard deviation
standard
of
covariance of
y.
deviation of
x,
y.
comma y divided by the standard deviation of x into standard deviation of y. So this is my correlation. And what is the range of correlation?
Minus 1
0
to
to
Minus
1.
1. Minus 1.
Minus 1
Minus
to
1 to
1.
minus
1.
1 to
So
plus
if
1.
my value is coming close to 1, I can say that it is
Strongly
strongly
connected,
positive.
ma'am.
And if it is close to
Strongly
minus 1, I can say that
Strongly negative.
No.
strongly negative. So by the graph also I can see it, right? So let's suppose if I have a graph and let's suppose this is okay. So what can I say about the correlation?
+1.
It's like
Closer to
close to
1.
1. Yeah, it's like close to 1. It's strongly positive. So in the similar way, if it is going downwards like this, then I can say it's like close to minus
Minus
1,
1.
right?
Minus
So in that way, I can say what about the correlation. Now comes the bounds. Okay. So the first thing is we have Markov's inequality. What is Markov's inequality?
Probability of the random variable
X less than
taking
equal C.
So the first thing is in Markov's inequality, my x is a discrete random variable and it will take only what?
non-negative
Non-negative
integers.
value. Okay, just remember that. It should be a discrete random variable and it should always take the non-negative values. Okay, then the probability will be that x is greater than equal to c is less than equal to mu upon c. Fine. This is my Markov's inequality. Then next term is the Chebyshev's inequality. What is the Chebyshev's inequality?
Probability of x minus mu mod greater than k sigma is lesser than or equal to 1 by k square.
Yeah. So basically this probability of mod of x minus mu is greater than equal to k sigma is less than equal to 1 by k square. Okay. And there is one more form of this. The other form is probability that mu minus k sigma, the x between mu minus k sigma and mu plus k sigma will be greater than equal to 1 minus 1 by k square. Yes? Yes or no?
Yeah.
Yes,
Yeah.
ma'am.
These are the two
Yes, ma'am.
forms which are useful. Okay? So just remember that between Markov's inequality and Chebyshev's inequality, if in the question it is only mu is given, only the mean thing is given, we will go with the Markov's inequality. If I have two values, which is mu and sigma, both of these values are given, I will go with the Chebyshev's inequality. Got the point?
Could you just repeat that once again, ma'am, if you don't mind?
Yeah. So basically, if in the question they are only stating the mean, okay, they're talking about the mean and my x is only taking negative values, I will go with the Markov's inequality. But in the question, they are stating both of these values, mu and sigma, then I will go with the Chebyshev's inequality. Fine?
Is it because of higher precision or?
Higher precision?
No, because for Chebyshev's also you have the mu, right?
I have the mu, but in the Chebyshev's we need the sigma as well, right? Do we have?
Okay.
When we have only mean.
Okay, then you have a choice, right? You can use Markov's also, right? So why is it that you prefer Chebyshev's is my question.
No, I am stating only this one is given, only mean. No, what do you call that? No sigma is given. Then I'll go with the Markov's inequality. If both of these values, mu and sigma, both of these values are given, then I will go with the Chebyshev's inequality.
Okay, okay. No, my question was, ma'am, so with just mu, you are able to calculate the value using Markov's also, right? So why is it that when sigma is given, you prefer Chebyshev's? Is it because
What's the difference? Okay, can you tell me the difference between both of these equations?
Yeah, I mean, I see that one has the sigma included in the formula.
No, I'm not talking about the sigma or anything. I'm just asking about what are you getting from these probabilities? Like what meaning you are getting? What are we finding out?
We are finding out the number of standard deviations a particular value of x is from the mean, right?
Correct. So that is my Chebyshev's inequality, right? And what is my Markov's inequality?
Isn't it the same, ma'am?
No.
Okay.
Here we are actually finding out the bound that my x bound that my x is taking values greater than some greater than some value, right? What is the probability that my x is greater than c? What is that probability? I'm finding out that thing. Here I'm checking the distance.
Okay,
standard
okay,
deviation,
okay.
right?
So the intent is actually different in both cases.
Yeah, correct.
Okay, okay. All right. So
Got the point?
yeah, so in one we are just checking the whether it's like greater than a
Greater
certain
than
value.
yeah, correct.
Okay.
And here we are checking the distance, the like what standard deviation my x is away from the mean.
Okay, okay. So the intention is totally different. Okay, ma'am.
Yeah,
I really thought one was like just a better version of the other.
No. Both have a different
Purpose.
purpose. Yeah.
Okay,
Ma'am,
thank you.
on the Markov's inequality,
Yes.
the basic form of the formula gives the probability that x takes the value c at least, right? Which means the lower bound. Is that correct?
No, this is like this. This is my upper bound. What is the probability that my x will be greater than some value? I need to check the low or upper bound. So what is the upper bound that my probability will be greater than some value? So this is my upper bound. You just okay. So just remember this thing. If I have a sign like this is upper bound.
Upper bound. Okay.
Okay.
That's the maximum value.
Yeah, correct. And if I have a sign like this is my lower bound.
Lower bound. Okay.
Okay. What is upper bound? Like this, my let's suppose I have some value, and these values like x1, x2, x3, these values should be less than equal to x. So this is my upper bound. So all the values will come under this. So this will be my maximum limit, right? My maximum number, correct? So this will be my upper bound. If I suppose my x is this and all my values are greater than this, so I can say that this is my smallest number and all the numbers will be greater than this. So this is my lower bound. Got the difference?
Got it, ma'am. So
Yeah.
will there be any question that comes like this, like calculate the lower bound using the
Yeah,
Markov
it
inequality?
will surely it will come.
If that case, how do we approach that problem? Here it
Yeah,
is
yeah.
showing
We will
us.
solve some questions and we will do it. Right now I'm just
Excuse
briefing
me,
out
ma'am.
the week 3 and week 4. Then we have some questions and we will solve that. Fine?
Okay.
Excuse
Ma'am,
me, ma'am.
Yeah.
What is the value of k?
Sorry.
What do we mean by k over here?
K sigma in the sense K is like the okay. Have you heard about 2 sigma, 3 sigma, 4 sigma, 6 sigma, something kind of like that?
Yes, ma'am.
Yeah. So K is basically my constant term. Okay. So it the difference can be 2 sigma, 3 sigma, 4 sigma, something kind of like that. Okay.
Okay, so we are trying to determine that what is the probability that this value of x is between 2 sigma from the mean.
Yeah. The distance between my X and mu is like 2 sigma.
Okay, so we are given. Okay, so then we use the formula 1 minus 1 by kx
Ah.
square and.
Ah.
Okay.
Okay.
Excuse
So
me,
this was
ma'am.
all. Huh?
Ma'am,
Yeah.
here you are talking about some deviation. Can you please just once again explain this deviation in first?
Deviation. You are talking about Chebyshev's inequality.
Yes, ma'am.
Okay. So basically, what is this? The probability that mod of x minus mu is greater than k sigma. What is x minus mu? Basically, this is the distance. Distance of x and mu. What is the difference between my x from the mean? Correct? This thing. Yes or no?
Yes, ma'am.
Yeah. So what is the probability, or you can say that, and this is greater than equal to k sigma. So I can say that, like, what is the probability that my x is away from mu by k sigma, or by what standard deviation my x is away from mu? Got the point?
Yes, ma'am.
Yeah.
Ma'am, but what is the practical application of Chebyshev's inequality? Like, how will the questions come?
Yeah, we will solve the questions and then we will know. Okay, I'm just briefing out the sum of the week. Okay, then we will move on to the questions. Okay.
Ma'am,
Okay, ma'am.
excuse me, ma'am.
Yes.
Ma'am, like the line is given in some question. I remember it is given to us. It is deviated by 1 sigma. So in that question, do we put k equal 1?
Yeah, correct. So I can say
Okay.
that my probability that mod of x minus mu is greater than 1 sigma.
Ma'am, I had one doubt. What is the
Yeah.
difference between the two equations of Chebyshev?
Which two equation?
The
Oh,
two
this one.
equations.
We have just opened it, na? Mod of x is greater than k sigma. I just opened it and I have the second form. That's it. In this,
Ma'am, can you write in this in the Marconi
this one
equation?
is basically what it's telling about the upper bound, and this one is telling me about the lower bound.
Okay. Okay.
Okay. Yeah.
Okay.
Ma'am,
Ma'am,
the Markov inequality also
I'm not getting your point. Can you repeat again?
ma'am, can we
like
write this Chebyshev form in the Marconi equation?
Huh? What?
Ma'am, can we write this Chebyshev inequality in the Marcon inequality in that form? Like there's
Markov's
a
inequality.
formula in the lecture: x minus mu greater than equal to c, less than equal to mu sigma square by c square. There is a formula in the lecture, so it says in a Marconi form, na?
X minus mu and c is like, yeah. So what you will be doing? So basically, from the Markov's inequality, you can have this kind of what do you call that? This Chebyshev's inequality. Basically, what we are doing in place of x, I am just putting x minus mu whole square. Okay. in place of x, I'm putting x minus mu whole square, and in place of c, I'm putting k square sigma square. So you just have to put the values and then you will get this thing. Okay? Yes or no?
Yes, ma'am.
Yeah?
Yes, ma'am.
Okay. So week 3 is done. Shall I move forward to week 4?
In Chebyshev's inequality, there's one version of it, right, which has got a epsilon. There's one version of
That-
it.
Epsilon.
Is it an epsilon or not a sigma, but it's an epsilon?
I think
like an,
you're talking about the weak law of large number.
see, it's
Epsilon is in that equation, not in this.
so so on the right hand side you have 1 minus sigma square by epsilon square.
On which side?
On the right side.
This here.
So on the left side would be probability of x minus mu being less than or equal to epsilon is greater than or equal to 1 minus sigma square by epsilon square.
Oh, okay. Yeah, that is also correct. So the thing is, you are saying probability of
x minus
mod
mu
of x minus mu greater than, right?
less than epsilon.
Okay, 1
being
minus less than epsilon
is greater than or equal to
1 minus
1 minus sigma square
by
epsilon square.
epsilon square. Right. It's the same thing. So let's suppose, so if you just compare this equation and this equation, so basically my epsilon is equal to k sigma.
Yeah.
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 Okay. Now epsilon is k sigma. So what is my k here? Epsilon by sigma, right?
Okay.
Yeah.
Okay.
So now
okay.
here, according to this, it will be 1 by 1. If you are taking this form, so it will be 1 upon 1 minus k square, correct?
Okay.
So in place of k, I am putting epsilon upon sigma. So this will be what? 1 minus 1 upon epsilon by sigma whole square.
Okay. Ma'am, okay, I mean, a very basic question. I mean, I was a bit lost when you were explaining epsilon is equal to k sigma. But why is epsilon equal to k sigma?
We are just putting it equal to this value, right?
Okay. It's just a
So
replacement.
I am just denoting my whole k sigma with an epsilon value. That's it.
That's all it is.
Yeah.
Okay. So what do you call such a value?
Which value?
The epsilon, is it supposed to signify something? Because I understand that k has a significance, because k means like the number of standard deviations.
Correct.
What is I mean, what's the use of epsilon then? I mean, it's you're just multiplying it with the standard deviation, right?
See, there are different forms. So in the sense, like some are just writing it k sigma, some are representing it by epsilon. So like, what's the difference? Like for like epsilon is like a constant term or something, you can say that. With like this like the difference between the distance between x and mu is like this is the distance or something kind of like that. So we are just representing it by epsilon, just to way the writing things. That's it.
All right, ma'am. All right, thank you.
Anything else? Week 3 is all clear. We will do the questions right now. I'm just briefing out. So like in 1 hour, just let's brief out all the weeks and then we'll go with the questions. Okay?
Yes, ma'am.
Yeah. So shall I move forward with the week 4?
Yes, ma'am.
Yes, ma'am.
Okay. Now in week 4, yeah, it is like, let's do it in a speed. Okay, so what was all there in week 4? So the first thing is we learned about the PMF of a discrete random variable. Then we learned about the CDF of a discrete random variable. Then this was about the discrete, right? Now from the CDF, we move on to the CDF of a continuous random variable. And then we moved on to the PDF, right? What is PDF? PDF is basically we are calculating the density. CDF is for the continuous random variable, correct? Okay, now. Okay, now for the CDF.
Before you, can you just give a basic conceptual understanding of what is a PMF to what is a PDF? I know these are for discrete and that's for continuous, but other than that, what is the concept level, if we can understand a little more.
PMF is just a probability mass function, right? For the discrete. So what is a PMF?
Probability of a random variable taking the value x.
Yeah, so basically if I say that my x is having some numbers x1, x2 and x3, so PMF is actually just a second. PMF is actually the probabilities associated with each of these values. Okay, so the probability associated with x1 will be what? P1. For x2 it is P2, and for x3 is P3. So these are my PMF. Okay, so PMF is actually the probabilities associated with each of the values of that random variable. Fine. That is my PMF. What is CDF? CDF is basically my cumulative frequencies, right?
Yes,
So if
ma'am.
I suppose if I need to find out probability that x is less than x2, it is probability of x equals to x1 plus probability that my x is equals to x2, correct? This is how I calculate for the discrete random variable. Now comes the CDF of a continuous random variable. Okay, so what is, okay, what is the, how do I write the CDF of a continuous random variable? It is basically probability, it is fx, which is probability that my x is less than equal to some value, correct?
Yes, ma'am.
Yes or no? Okay, now what are the basic properties of a CDF? That fx is non-decreasing.
Non-decreasing.
Second, if my x is tending to minus infinity, then my fx is
Zero.
0. Then if my x is tending to positive, like in
Fx is 1.
Fx is 1.
x is 1, then what else?
Conversion, ma'am.
In graphically, if we say for a continuous CDF, we see there are no jumps, correct? And if there are no jumps, then the probability at a particular point will be equal to
0.
0. So these are some of the properties for CDF of a continuous random variable. Got the point?
Yes, ma'am.
Okay.
Ma'am.
So this was.
Ma'am, I have a doubt in Marconic and Chebyshev. Ma'am,
Yeah,
in Marco,
let me just complete this and we will come back to the Markovs and Chebyshevs. Okay?
no issue. Okay, ma'am.
Yeah. Okay then. So this was all about the CDF of a continuous random variable. Then comes the PDF. What is a PDF?
Probability density function.
Probability density function. Okay?
Yes.
It is denoted by small fx. Okay? So it is basically what? If x is given to me, which is probability that my x is less than equal to x, then I can find it out by from minus infinite to x, fx dx. Okay? Now, what are the properties of fx?
Minus infinity to plus infinity would be 1 again. Right? When you integrate it.
Yeah, so the first thing is it should be greater than equal to 0, and the second thing is if I integrate the whole area would be equal to 1. Then what is the support? Support of x, it is basically what?
The range of
x in which my fx is
greater than equal to 0.
Greater than equal to 0. Right?
Ma'am, is it greater than equal to 0 or only greater than 0?
What is the majority?
Greater than 0, right?
Greater than 0. So always remember this. Support of x should be that in which my fx is greater than 0. This thing is important. Okay?
Okay.
Fine.
Ma'am, can you please again show the screen related PDF and continue?
Ma'am, could you explain the PDF again? I did not understand very well.
Sorry, once again.
Could you repeat PDF? Could you explain again the three
PDF
properties?
is basically what? PDF is basically if I'm drawing a chart, let's suppose. Okay, this is my PDF, the whole thing. Okay, it is going from minus infinite to infinite. This whole thing is my PDF. From this PDF, if I have to find out the CDF, so let's suppose this is my x naught. Okay, so I need to find out that my probability of x is less than equal to some x value. Let's suppose this is my not x naught, this is x. Okay, so what will it be? I will be integrating this. I need this whole area, correct? So
Yes,
if I
ma'am.
need this value, it will be going from, I will be integrating this PDF from minus infinite to x. Okay, fine. And the properties are my fx, my PDF should be greater than equal to 0. My whole area should be equal to 1. And the support of x should be that my fx is greater than 0. Fine?
Yes, ma'am.
Okay. Anything
So
we
in
Anuj?
the graph, what is PDF?
Hmm?
Is it in the graph that you just read? You were saying that the area under the curve is represented by CDF, right? The big fx. And what is
Yeah,
PDF?
this one, right?
What is PDF? In the
PDF
graph,
is
where will be?
the whole graph, right? This is all my this PDF.
You mean the height of each?
The function, the curve, the curve.
Yeah.
The entire
The
curve.
whole thing.
But it will represent a height at every point, right?
No, let's suppose my function is like x cube. Okay. So if I have to draw a graph, it would be like this thing, right? And my data is going from 0 to 1. So this is like 0 and this is like 1. So this whole thing is my fx. Okay? Function.
I mean, I think
area under the curve.
area under the curve would be the large fx, no, ma'am?
The
And
large fx, no, man.
Big
yeah, and the curve alone is the small fx.
The curve entirely, which means the height. At any point, it will become the height, right?
Yeah, I mean, the curve is expressed with a function, right? Like x cube defines a curve, or x square root defines a curve. Just the line, that's the small fx, and the area under that line is the big fx, is what I understand, ma'am. Can you just clarify that, ma'am?
Yeah, okay, just let me just check.
Like
One
from
second.
the CDF, we have to take the derivative to get the PDF.
Yeah, but so when you take a derivative, you're basically taking the area of a curve, right? Under the curve to the x-axis, right? So
integration is taking the area.
Yeah, so that's what you get, right?
The,
I mean,
the integration, right? But
yeah, integration gets you the area. Sorry, not the
I'm
derivative.
asking about the PDF. What does the PDF represent graphically? So they were saying that that's the function line, that the curve that it is representing, not the area under the curve.
Area, I'm presuming, is the CDF or
the CDF. Agree,
Yeah.
agree.
Yeah, exactly.
I wasn't very sure about the small fx. What does it? I mean, it could be the height, right? At every point or the between the intervals, it represents the height of that particular interval, right? So, yeah, collectively, the fx will become a curve. But if you want to really understand, then it becomes the height of each point or the each interval, rather.
Yes, I mean, that's what I guess functions are. I mean, they just define.
Right.
Ma'am, actually, I had a doubt. Can I please ask it?
Yeah, sure.
Actually, ma'am, I was a bit confused about the Markov's inequality and the Chebyshev's inequality. Actually, I was not getting as you said, the Chebyshev inequality can have both upper bound and tells about upper bound as well as the lower bound. As in the same, does the Markov's inequality also tells us about the upper bound and the lower bound, or it only tells about the upper bound itself?
No, both can tell the upper bound and the lower bound.
Both can tell the upper bound and lower bound, but in our syllabus, only upper bound is there for Markov's, right, ma'am?
Yeah, you can change it to a lower bound, right?
Yeah, I know, but for our convenience, right now we only have the upper bound, right,
Hmm.
in our syllabus.
Yeah, not in the syllabus. Like they have just told the upper bound. So you can solve it and for the lower bound, right?
Okay, means we have the formulas, but currently not right now. They might not ask about the lower bound from the Markov's inequality equation. Is it so?
No, they can ask.
Okay. And if asked, what will be the formula for the lower bound in Markov's?
Yeah, I'll just come back to that. Let me just finish this week 4. Okay.
Okay, done. Thank you, ma'am.
Yeah. Okay. So you're basically saying this is my fx and this whole area is my capital Fx. You're saying that?
Yes, yes, ma'am. We just wanted to
Yeah.
confirm whether our
Okay.
understanding.
So the main thing, if I have to ask you this property, that my from minus infinity to fx, the whole this thing is like we are calculating the area, correct?
Yes, ma'am.
Yes.
And this whole area is equal to 1, right? We are talking about this whole area.
Yes, ma'am.
Yeah.
And that is the capital Fx, right?
That is not capital Fx.
That is capital Fx, right?
No, that is not capital Fx. You're not finding out capital Fx. Capital Fx is that the probability that some value less than that. That's it. Yeah. So this is not a capital Fx. This is just we are finding out the whole area.
When you say
under
this,
the curve.
what do you mean, ma'am? That entire
If we
minus
change
infinity
the
to
upper limit from infinity to a particular value, that will become the. If we change the upper limit to x, then it will become the.
Yeah, then it will be an
then
Fx.
it will become the capital Fx, right?
Yeah. So Fx is basically what? The particular area. In this, if you see, this is my particular. I need to find out this particular area. Then that is my Fx. This whole area is my Fx.
The capital Fx. Correct.
Yeah, correct. So, okay.
Miss, capital Fx is the notation for PDF. Is capital Fx is the notation for PDF?
No,
Small
CDF.
CDF, okay. CDF, okay.
So CDF is the particular area which we are taking from
Finding out.
PDF, right?
Correct.
Area which is we are taking specific area which we are selecting is the CDF, right?
Ma'am, could you just briefly explain what support is, just like the statement?
Just a support is if so Fx is basically I think that the curve is my Fx. Okay, and the area
I mean,
under
small
that,
Fx,
thing,
small curve.
small Fx.
Curve
And
is
the
small
thing
Fx.
is, and Fx is also basically we are talking about the curve. So if I say that if I need to find out from x to 1.5, sorry 0.5. Okay, so what will it be? This is my graph. This is like 1/2. This is my 1, and this is 0. So basically, I need to find out the area under this curve, right?
That's what you integrate and find out always, no?
Yeah, that is what. So,
So-
I'm finding out this part, correct? The area under this curve. Similarly, what is my Fx? Fx is basically the whole curve, okay? And the integration, the whole, and this thing is basically what? The area under the curve, right?
Yes,
The
ma'am.
area under
Yes,
the curve
ma'am.
should be equal to 1. So basically, they are just talking about this whole, this curve, that's it.
So if we are
So the
taking
curve
the
is
area,
basically my Fx, and capital Fx is basically what? The small part of Fx that we want to find out. Okay? Yeah. That's it. Okay,
Ma'am,
somebody was?
Yeah, I think he wanted to find out about support.
Support, right? Okay, so what about support?
Yeah, just the definition of support, what it actually means.
Support is basically, see, in the discrete case, we learn, we have range, right? What is
Yes, ma'am.
range? Range is basically what all values that X can take. So it was basically, it can take 0, 1, 2, something like distinct values, right?
Yes,
In
ma'am.
the case of continuous, we say it as a support. That's it.
Okay.
And the main thing is the support, the X should be, should contain that value in which my fx, this is a PDF, should be greater than 0.
Okay.
That is the
Okay.
whole point. So if you see here, let's suppose I am taking this x cube and 0 less than equal to x and this one. So if I need to find out the support of x, what will it be?
It
It
will
will
be
be
all
0,
the values from between 0
0
and
to 1, right? So,
okay.
so this open bracket states that it can, the support of x is great, not equal to 0, but greater than 0 and less than 1. Got the point?
Okay. Okay. Got
Yeah,
it. Got it.
that is my
Yes.
support. Okay, this was all about PDF. Anything else is remaining in week 4? That's it, right?
Yeah. Again, about support, ma'am.
Hmm.
Question about support.
Yeah, tell me.
Definition, it says it's above, it's greater than 0.
Hmm. Hello. Hello. Am I audible?
Yes.
Ma'am. Ma'am,
Yeah.
so
Is it my connection or his connection?
No, it's
I don't
his
know.
connection.
Okay. Okay.
here now the PDF is the whole area under the curve, right?
Yes.
Fx is a function that is line. Below
Hmm.
that the whole area
And
is the PDF.
correct.
And capital Fx is the partial area which we are finding out.
Trying
from
to find out.
the, right?
Partial area in the sense the probability. What is the probability? What is the area under this value? That's it.
Okay.
Cumulative value. Okay. Yes, of course.
Ma'am, I wanted to, ma'am, can you please clarify that point which I've written about no jumps and then fx equals to fx of x equals 0? Yes, ma'am, this fourth and fifth
Okay.
point in CDF.
So,
What, ma'am, can you please explain graphically what they signify?
this is my graph of CDF, right? It's continuous. Then it's going
Yes, ma'am.
constant, right? So, and this was my graph of a discrete case, right?
Yes, I'm correct.
Correct. So here this probability at a particular point is basically this jump. This is my, if I see the jump, then only I can calculate the particular probability, right?
Ma'am, this probability, this jump, this gap is basically the probability of the upper ladder.
Let's suppose this is like 1, this is 2, this is 3. So if I need to find out the probability of 1, it will be this jump, right?
Yes,
Yeah.
ma'am.
Yeah. In this case, are you seeing any jumps?
No,
It's
ma'am, it's
continuous,
continuous.
right?
Yes, ma'am.
So if I can't see any jump, can I calculate any particular probabilities? No, right?
No, ma'am. Ma'am, it is
Yeah.
the height of that curve at that point, isn't it, ma'am?
This is my fx, no?
Yes, yes.
That is not a probability. This is my fx, cumulative thing. I need to find out the probability at that
Small f,
particular
small
point.
f of x, yes.
Yeah, correct. Correct. So I need to calculate that probability. So here in discrete case, what we used to do, we used to subtract this whole thing with this thing, correct? Then only I used to get
Yes,
this
ma'am.
thing. That is
So
my
we can't
particular
do this
probability.
here.
We can't do this in. That's why this is used for a continuous random variable, in which we don't see any jump and the probability at a particular point is 0. That's why this is known as a continuous random variable. Okay?
Okay, ma'am. So this property is basically for the
Yes.
CDF function, continuous CDF function.
Continuous one.
Okay, understood. Thank you.
Hello, ma'am.
Yes.
Ma'am, I have a similar doubt. This f of x and probability of x. I just equate both. I just consider both of them as equal.
Which one? Which one?
The continuous one, the continuous graph,
F of x and
and probability of x. I just consider both of them as equal. Could
why?
you please differentiate both of them?
How you are considering both equal?
Oh, I don't know.
Okay. So what do you mean by fx?
The function.
No. I'm talking about, you're talking about this fx, right?
Yes, yes, yes.
Yeah. So what is this fx denoting?
It's talking about the function.
What function? CDF, right? Cumulative thing.
Yes, yes, yes,
So
yes.
this is basically talking about my cumulative distribution function. That it is
Okay.
accumulating the probabilities, right? That is my
Okay.
CDF. And what is probability of x? It is basically the probability at that particular. What is the probability of occurring that value? That is
Okay.
the probability.
But if they ask the CDF at x equals 3, we are not able to calculate for the continuous. Am I right?
We can calculate the CDF for that
No,
particular
ma'am,
value.
for at a particular value, 1, 2, or 3.
We can have CDF for that particular value.
Okay.
We can't have the
We'll go through.
probability, but we can have the CDF. This graph is
Yes,
basically my
ma'am.
CDF, right?
Yes,
If I, this thing is
that
like
is,
0.5.
this is the confusion, ma'am. This is the confusion. Now, this time again, I consider both of them as equal. I just misinterpret. I don't know why.
Acha.
Okay.
This is my graph. What is my
Okay.
x-axis denoting? It is fx.
Okay. Why?
Okay.
Yes. Okay.
Okay. This is 2. This is like 0.3. Let's suppose. I need.
Okay.
What is the value of f2? Just see the graph.
0.3. Let's say 0.3.
0.3. Can you tell
Yes,
me the probability of x equals to 2?
No, ma'am.
This is fx and this is my x. Where is my probability? Just tell me that.
Nowhere.
Nowhere. So can you tell me the probability at a particular point?
No, ma'am.
So it is 0, right?
Yes.
Now you got the difference?
Yes, ma'am. Yes.
Yeah.
Okay. Thank you.
Okay. Yeah. So that's it for week 4. Any other doubts? Shall we move on to the questions?
Ma'am, I got disconnected while I was like, while I had a question and while we were talking. So it's regarding the support. So my question was that in that little sketch that we were discussing over some time back, so when x was equal to 1, the probability CDF was already also equal to 1. So beyond that, x had no meaning, right?
And once again, what?
So in the sketch, where you've drawn the black hatch. Yeah, below that, that denotes 0 to 1, right? And so at what point are you achieving a CDF of 1 where you've drawn the black hatch, right?
From 0 to 1/2, right?
1/2, yeah. So beyond that, x has no meaning, right? You don't really get a value of x, right? Because your probability is over. The probability is after that is 0. I mean, this is the x-axis is representing different values of x, right, as a continuous random variable. Yeah. So after 1/2, x doesn't take any value, right? Because your probability gets over by then. Maximum you get is like 1/2. After that, the continuous random variable is not going to take any value on the x-axis, right?
It can take between 0 and 1. It can take any values, no?
Okay,
yeah,
it's between 0 and
after that, like it will not. And the
but after 1,
meaningless
let's say,
after 1, right?
After 1, it doesn't have any meaning, right?
After 1, it doesn't have any meaning because the range is just going from 0 to 1, na?
Okay, so that is what I meant. So here, when you say support, you should only mention where your probability gets over, right? Which is basically when your CDF hits 1, whatever
PDF,
your x PDF is it? Okay.
My fx, the x should be that, my fx should be greater than 0.
Okay.
The function should always be greater than.
So after
0 to 1, sorry, I just wanted to clarify here that the 0 to 1 is only for the capital Fx, which means it's only for the y-axis that we should be working about 0 to 1, right? So, because many problems that we have solved itself has a lot of x values that are greater than 1 and we still have Fx. So I think the 0 to 1 is applicable only for the y-axis. whereas the x can take values even more than 1. That is my understanding.
Is that so? I mean, so your support, does it mean everything
Support
beyond?
takes values even more than 1, right? That is, so the 0 to 1 is only for f of x, which means the y-axis has a restraint of 1, not the x-axis. That is my understanding.
If I may add my input, right, this 0 to 1 in my understanding is that it represents the probability. So the support is nothing but what value of x that it can take, so that the f of x can or the probability comes between 0 and 1.
That's my understanding also. So that's my question. So beyond 1, it has no meaning, right? Because x cannot take any value beyond 1.
No,
So
it's
shouldn't
not x. It's not x that is taking values between 0 and 1. It is f of x that takes values between 0 and 1, right? The area under the curve is totally to be 1.
Area should be up to 1, right?
Yeah, but in this particular case, even the x is shown as taking the value up to 1. I mean, it could have been 100 also, it could have been 50 also, but it's just that in this particular case,
Yes,
it's 0 and 1.
But it is very much possible that x can take more values, but the f of x will always be capped by 1.
Yes, but in this particular case, let's say that 1 is represented as 50, let's say. So my question is the support only from 0 to 50, or does it mean 0 to infinity, plus infinity, you know?
The thing is, if I say a question is fx equals to what I say? Let's suppose this is x cube. Okay, I've just written this. So if I'm making a graph, the graph of x cube is like this thing, right?
Yes, ma'am.
I'm not specifying anything. The range of x, right? Now in the question, I'm stating that my x value is taking from 0 to 1. So which curve will be there? It will be this first quadrant, right?
Yes.
Yes, ma'am.
Right? So that's it. So this is so they are stating that my x is taking from value 0 and 1. So I will be taking this curve.
Ma'am, could you take another function, for example, x square?
Yeah. Any other function can take more values than 1, right, ma'am? That's what he's asking.
See, that
It's
is
not always
that
a
is not.
constant
We are
that is between 0 and 1.
just a second. The thing is, I am just stating that this function, this function,
yes.
right? This function is taking values that this is like x cube, right? So this function is just between these values. That's it.
Yeah, but x cube takes values up to
range-
infinity, right? X cube goes on forever, no? So
x cube goes on forever in the sense.
I mean, x can take any value in a x cube, right?
It should be between x 0 to 1. That's it. Any values between 0 to 1.
Okay. Okay, but it's a continuous random variable, right? So x can actually take any value.
But I am defining a range of x.
Okay, you are defining. So, ma'am, for just for our argument's sake, in this class, can we just define it as 0 to 25 for now?
You can define it.
Okay, so
the range can be anything.
Yeah, so in this case, you have a continuous random variable which value of which is set between 0 and 25. So is that the support here, or is it
the support will be what? The 0 and 25.
Okay.
So this is my support.
Okay, that's what I wanted to know, ma'am. Thank you.
That's it.
So the support is actually what we are trying to define for that limit, like ask the limit for
so the main thing is the support should be that in the sense that my fx should be greater than, should coming out to be greater than 0. So if I put close bracket 0 and 25 open bracket, that means it is taking value 0 as well, right? But in that case, my fx is coming out to be 0, correct? And I don't want that. I need my fx should be greater than 0. So that's why it should be open bracket 0 and 25 open bracket. Got the point?
Okay.
Yeah. Now the doubt is clear?
Yes, ma'am. But 25 can be closed, right?
25, why? I'm just denoting it should be less than 25 now. If it is equal to 25, then you can say it is a closed bracket.
Okay. That is it's just arbitrary. I mean, that's what we've decided for this in this instance, right? That's all.
Now it's fine.
Okay, perfect, ma'am. Thank you.
Yeah. Shall we solve the questions? Do you have any more sessions after 8?
Yes, ma'am. Maths.
Yes, ma'am. Maths session.
Okay,
would it be okay if some of us stay back and continue our understanding, because
Yeah, those who don't have any like
we can
session
probably
then.
share the recording with others as for that.
Yeah, sure then. Okay, then fine. Okay, so this was all about week 3 and week 4. Okay, we are done with the summary and everything. Shall we proceed with the questions?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now. Okay, then. So this is my first question. You guys have pen and paper?
Yes, ma'am.
Okay, then. So the joint beam of two discrete random variables x and y is given in the following table. In the table, alpha is any positive real number. Find the value of alpha such that my covariance is coming out to be 0. Solve this and tell me the answer. Okay, you can see the answer, but I need you to solve it. Have you guys done?
Ma'am, doing.
No, ma'am.
Okay. So in total, I guess I have 13 questions in all. So let's try to do it. Okay, maximum questions if I can. 5 or 6. Any questions are there? 14, yeah, 13 questions. 14 questions.
Ma'am, can you just show me that table again?
Done, ma'am.
Ma'am,
So
screen
how
is
did you?
not visible.
Huh? Screen is not visible to anyone?
Ma'am, give us 2 minutes.
Ma'am,
We'll
it
be
is
done.
visible.
2 minutes.
Yeah, yeah, sure.
Sigma is equal to 6.
Hmm?
6 answer.
Yeah, the answer is 6. Find the value of alpha such that covariance is 0. So okay, I don't need to solve this question. Just tell me the method that you have done. Okay, then we will move
Ma'am,
forward
we
to the.
use this formula and putting
Hmm?
equal to 0, and then it's fine.
Okay. Let's one or two person are solving the question, right? So let's wait for that and then answer. Yes, Sakshi.
Sorry, ma'am, by mistake I raised hand.
Okay. Is it done?
Yes, ma'am.
What about others? Okay. So the main thing is here they are asking find the value of alpha such that my covariance is coming out to be 0. So what is the formula of covariance?
E
E of
X,
xy.
Covariance of?
Go on.
Expectation of xy minus expectation of x into expectation of y.
Of x and expectation of y. Correct? Okay, so they are saying my the covariance is 0. That means my expectation of x and y is equal to expectation of x into expectation of y. Correct?
Yes.
Now.
No, ma'am.
Huh?
No, it's maybe wrong. It's not ma'am independent.
Sorry?
Ma'am, expectation of xy is equal to expectation of x into expectation of y. It's only in independent case.
No, if my covariance is 0, this covariance is 0, right? 0 equals to expectation of x into y minus expectation of x into expectation of y. Correct? Now I can state it as
No, ma'am. That means covariance xy is equal to 0. So that means it is not. It is independent. It is not independent. I mean, we cannot write. Only independent case we can write, ma'am. Expectation of xy is equal to expectation of x into expectation of. If covariance xy is equal to 0, we cannot say x and y are independent.
Is talking about covariance is equal to 0, then the xy are independent or not. He's talking about that, ma'am. He's talking something else.
Okay, so just tell me the steps. How did you solve this question?
Ma'am, it's a discussion. First of all, we find value of expectation of x by x into y into
First, you
PMF of
calculate the
x.
expectation. What is the expectation of x?
Ma'am, it's a random.
Half plus 1 by alpha.
Sorry?
4 by 12 minus 2 by alpha.
4 by 12 minus 2 by alpha.
Yes, ma'am, that's what I got.
Okay.
It's the expectation of y, no?
Given that x and y will be independent, right, ma'am?
Hmm? And what is my expectation of y?
Half.
Just half?
1 by alpha minus half.
1 by alpha minus half. Everybody is getting this answer?
I'm getting
Ma'am.
different ones.
Ma'am, have you
Sorry?
just reversed the expectation value of x and expectation value of y? Because those are different.
What?
Ma'am, this covariance of x and y is equal to 0. That means x and y are uncorrelated. Then we can think as like x and y are independent.
We can't say it, right? So every time we can't say that they are independent, right?
That uncorrelated means we can't think like that.
No. That is not necessary. For each of the, like every time, it's not necessary that if my covariance is 0, it will be coming out to be independent.
Okay, ma'am.
Okay. Okay. So everybody is getting this answer. Expectation of x as this and expectation of y as this.
For me, I'm getting different. I may be wrong, but
Ma'am, even I am getting different. I got the interchanged one as
Maybe this
expectation
might be
value
wrong.
of y equals to
Yes,
4
ma'am,
by 12
expectation
minus
of
1
x, y is equal to minus 1 by 6 plus 1 by sigma.
minus 1 by 6 minus 1 by sigma. That's I got it same expectation of x and y.
Plus 1 by sigma, maybe. Minus 1 by 6 plus 1 by sigma.
So that means I have to solve
that-
it.
Yeah, could you please solve it?
Okay. So here we have, okay. So expectation is, what is the probabilities here? 1 by 12 plus 1 by 4. This will be 1 by 3 minus 1 by alpha. And this is coming out to be 1 by alpha minus 1 by 2. Right? This is my fx. And what is my fy? 1 by 12 plus 1 by alpha. This is 1 by 12, and this is 1 by 2, and this is 1 by 4, 1 by 6. This is 5 by 12 minus 1 by alpha. So I've got the marginal distributions, right? So now the expectation of x will be what? Minus 1 into 1 by 2 minus 1 by alpha plus 0. So this is basically 1 by alpha minus 1 by 2, correct?
Ma'am,
Yes,
the
ma'am.
5
No,
by 2.
no, it is minus 1 by 2. Oh, sorry. Yeah, 1 by alpha minus 1 by 2. Correct.
Yes. Okay. Now expectation of y, it is minus 1. This will be minus 1 by 12 minus
You
1
got
by
the
alpha.
correct values before as well, but the expectations of x and y were interchanged.
Sorry?
How expectation of x is minus 1?
Huh? I'm not getting your point. I'm not able to hear you.
how the expectation is -1 into -2 minus 1 by alpha plus 0.
Can anyone explain?
Jyoti, may I know what is your question? Sorry.
How we are expecting from the marginal, we are calculating E of x, right?
Yeah, so it's the way we compute the expected value of x, right? So whatever the value of x that it takes, we have to multiply it with the marginal of that particular x. Say for example, x is taking -1 means we need to multiply that with p of x is equal to -1, which in this case is 1 by 2 minus 1 by alpha.
Okay, okay. Thank you.
This is my expectation of xy. These are my values of expectation of x. These are my values of expectation of y. And this is the value of expectation of xy. Is it correct or not for everyone?
Yes, ma'am, correct.
Sure?
Yes, sure.
Yeah. Now, the next thing is
Sure,
it
ma'am.
is given that covariance is 0. So what is covariance? Expectation of xy minus expectation of x into expectation of y, correct? This is 0. So what is expectation of xy? It is basically 1 by 6 plus 1 by 2, right? 1 by alpha. Now, minus what is expectation of x? It is 1 by alpha minus 1 by 2 into 1 by 3 minus 2 by alpha. This will be equal to 0. Now, have you guys solved this equation? Do I have to solve it?
I mean, we're getting
Yes,
a
ma'am,
lot
solve.
of
No,
complex.
ma'am. No.
Solve, ma'am. Sigma square minus 8 sigma plus 12 is equal to 0.
Getting two values for alpha actually.
Could you please give us few minutes? We can solve it once again, all of
Yeah,
us. The
just
same
try to
question.
solve this equation. Yeah, just
Yeah.
try to solve this equation and tell me now you are getting the values or not.
Ma'am, sigma square minus 8 sigma plus 12.
Okay, what sigma square?
Minus 8 sigma
Huh?
plus 12 is equal to 0. 12,
2?
12.
12
1, 2, ma'am.
equals to 0.
0. Yes, ma'am.
Okay, so this is it.
Minus 8 sigma, we can break minus 2 sigma, minus 6 sigma. Minus 2 sigma.
You mean alpha, right? Are you saying sigma?
Ma'am, yes, ma'am. Alpha is equal to 6.
Alpha is coming out to be 6.
Yes, ma'am.
Ma'am, we can common 1 by sigma.
Yeah, we can take the LCM, right? So LCM will be 3 alpha square, 3 alpha.
Ma'am, it's wrong equation, ma'am.
Ma'am, there is actually another method as well. From that method, it will be a much better approach, I guess.
Use this 3 numbers. Everybody is getting that answer? Alpha equals to 6.
Yes, ma'am.
Yes,
Now is
ma'am.
it fine? Okay.
Yes,
Shall
ma'am.
we
Ma'am,
move-
can you please zoom out the screen? So,
Sorry?
ma'am, can you please show the complete answer in one screen so that I can take screenshot?
I will share the PDF.
Okay, ma'am, no problem.
Okay. Shall we proceed to the next question then?
Yes, ma'am.
Yes, ma'am.
Okay. Now the probability mass function of a random variable x is given. We have defined y, find the expected value of y. Solve this and let me know.
Done, ma'am.
Everyone?
No, we are still computing.
Okay.
I'm wondering like how come they are so quick.
It's fine.
My answer should be 269.4.
Answer is 209.
209.
Yes,
How many of you are getting 209? How many of you have solved? 9.1.
I'm getting 209.
209, everyone? Okay, let them
Yes,
solve.
ma'am.
Rohit, what value you are getting?
Ma'am, correct 209. I divide by 2, so it's
Has
yeah,
everyone?
it's correct 209.
So those who have not solved yet, have they solved, or do you need more time?
We can discuss on the approach.
Ma'am, this type of question will come in exam or no?
Yes, this is the previous year questions, right?
Ma'am, okay. Level is same.
Okay. Level? Which level?
Level.
Okay. So here, can you just put yourself? Okay. So we need to find out the expectation of y. Okay. Now I can write this as expectation of 2x plus 1 whole square, correct? Or the one way is I'm just opening the brackets. So it's like 4x square plus 1 plus 4x. So now this will be 4 expectation of x square plus 1 plus 4 into expectation of x. So I need to find out, in this case, I need to find out expectation of x square and expectation of x. This is one method. Then the second method is what I'm going to do. I'm going to find out the values of 2x plus 1 whole square. Okay. So if my x is taking values like -3, 6, and 9. Now, what is my y? What values y will be taking? For
25,
-3 is
169.
no, for -3 it will be -6 plus 1 -5, 5, 5, 25. Okay. Then 6, 6, 2, 6, 12, 13,
169, 169, 361.
361. So these are the values that my y is taking. Okay. And the probabilities associated with it is basically 1 by 6, 1 by 2, and 1 by 3. Now we can calculate the expectation of y. It is basically 25 into 1 by 6 plus 169 into 1 by 2 plus 361 into 1 by 3. Correct? So if you solve this, you should get 209. Is this question clear?
It's a little decimal, right, ma'am? I mean, it's not a.
Yeah, I'm also getting like 209.000 and something.
Are they writing? Sure.
It is
I
not a
don't have to
perfect
check.
integer.
It is
Ma'am, I am
54 by 6.
09.
I got 208.9.
It's 209.
Let me just check. 20.
So everyone's getting a round figure, is it?
Yeah, I got about 209.
I am getting
003333.
1254 by 6, which is 209.
169 divided by
209, ma'am. Exactly 209.
261. Okay, let me just see if I'm also getting that.
1254 by 6.
I'm getting direct answer 209. How are you guys getting
Yes,
decimal?
ma'am. No, ma'am, not
Maybe
in
it's a
this.
multiplication error or something.
Yeah, maybe because I'm also getting 209.
1254 by 6, ma'am, is equal to 209.
Just check it once again, huh? Because I'm also getting 209. Just check your calculation or something. Okay. Shall we proceed to the next question?
Sure, ma'am.
Yeah. Okay then. Next question is, okay. Let x be a partial random variable with mean equal to 10. Which of the following bounds can be obtained using Markov's inequality?
Ma'am, in option 2, is 20 D, it is written 26 or 25?
Where?
In this question, option D.
Yeah, option D. The answer is option D.
Option D, ma'am.
Shouldn't that
Option
be
D
10 by
is really
26?
correct, ma'am. At the place of 26, it may be 25. Ma'am?
Sorry?
I mean, that's
Option D
25,
is
not
not
26.
correct, ma'am. At the place of 26, maybe 25.
Just tell me the option. Which option is correct? So that means none of the above?
Yes, ma'am. None of the above.
Fourth option is correct, right?
Huh?
Fourth option is correct, D.
It looks like a small error there in the question.
D option is correct.
I go
Okay.
with D. I go with D.
You will go with D. and most of them will go with none of the above, correct? Yes?
Mhm.
Yes, ma'am.
Yes, ma'am.
Yeah?
Yeah, I'll go with D. Yeah.
In question, the typing error.
So the question is correct. There is no typing error.
So the reason why I go with D is the
Yeah.
probability of X strictly greater than 25 can also
Hmm.
be written as probability of X greater than or equal to 26.
Yes.
Very
I'm
good.
going with
Correct. So
Yes, ma'am.
Markov's inequality is basically what? The general term. Probability that X is greater than equal to C is less than equal to mu by C, correct? This is my equation. So so I can write this as probability of X. If it is saying that X is greater than 25, I can write it as probability that X is greater than equal to 26.
Yes, ma'am.
Now I can write this as it is 10 upon 26. Now you got the point? The same thing was cleared yesterday, right? Yeah. Yesterday also I cleared this doubt.
Yes, ma'am. My
Yeah?
doubt.
Yeah, correct. The same thing. The same mistake, everybody done. Huh?
Um, does that mean that the X has nothing to do with the poison distribution?
The X is what?
How did we get 25?
What 25?
No, Bhumi,
The
to answer
option
to
D.
your question,
We are checking the from options. It's not given. We are just equating the formula with that.
That does mean poison distribution is just given in the question, but has nothing to do with the options, right?
yes, it is kind of a distraction
Tricky
because
question.
yeah, if you and in my understanding, either it is Markov's inequality or Chebyshev's inequality, right? The concept is that even if you do not know what type of distribution that uh, the random variable takes, right? We should have some sort of a mechanism to check the bounds of that random variable. So whatever that we discussed or seen so far, we never worried about what is the underlying distribution that the random variable takes. Ma'am, you can correct if that.
Yeah,
wrong.
correct. Okay. Okay. So this question three is fine. No doubts. Is it clear?
Yes, ma'am.
Shall we move forward to the next question then?
Ma'am, in question number 2, how did you get the y values, ma'am?
Okay. So let me do one thing. What is the next question? Okay. So can you guys just read the question and note down the values? Then till then I will just explain question 2 to him. Just let me know when you are done with the. Have you guys noted down? What about others? Everybody done? Okay. Okay. So what was your doubt?
Ma'am, how did you get the y value 25, 169, and 361?
So this thing?
Yes, ma'am.
So my y is basically what? 2x plus 1 whole square, correct?
Yes, ma'am.
My x values they are taking is like -3, then 6 and 9, correct?
Yes,
So
ma'am.
what my y will be? So the first thing is, first I'm putting the x value as -3. So it is 2 into -3 plus 1 whole square, correct?
Yes,
So if
ma'am.
you solve this, you will get 25.
Yes, ma'am.
So my y taking value is like first is for -3, it is 25. Then
Got it.
again, 2 into 6 plus 1. So you will be taking out all the values, checking
Yes.
for all the values of x. Okay?
Yes, ma'am. Thank you.
Done, ma'am.
Done?
C, yes, ma'am.
You're getting 1208?
Yes, ma'am.
What about others?
No, ma'am.
No?
I'm doing.
Okay, just do it and let me know.
Ma'am, this PDF, where can I find?
Okay, just give me 2 minutes. You guys solve and I'll just give me 2 minutes.
Ma'am, can you send me PDF on chats?
Yeah, so somebody was asking something. Are you guys done? This question?
Unable to take any.
Yes, ma'am.
Not able to do it?
Yeah, not able to take enough.
Okay, let me just give you a hint. Okay. So basically, they're asking me variance of x into y. So I can write this as expectation of the xy square minus expectation of xy whole square. Correct?
Yes, ma'am.
So this is basically expectation of x square y square minus expectation of xy whole square. Yeah.
Yes.
Now they are saying that x and y are my independent random variables. So if they are independent, can I say expectation of xy is equal to expectation of x into expectation of y?
Yes, ma'am.
And similarly, expectation of x square into y square is equal to expectation of x square into expectation of y square?
Yes, ma'am.
Yeah, I can say that, right? So just you have to calculate. So that's it. So first you calculate expectation of x square, expectation of y square, then expectation of xy whole square. How can you calculate expectation of x square?
Ma'am,
Because
expectation is given, variance is given. We just put the form.
now you got the hint. Now can you guys calculate the value?
102.
Can I get the value of expectation of x square?
102.
102. Expectation of y square?
404.
Okay. And expectation of x is basically, what is my expectation of x? 10.
And y is
Expectation of y is 20. Are you guys getting expectation of x square and y square? The values?
No, ma'am, please solve it.
Can you please solve me?
Okay. So variance of x is what? Expectation of x square minus expectation of x whole square. Correct?
Yes, ma'am.
Yeah. So I need the value of this. I have this value, I have this value. Can I find out expectation of x square, which is variance of x plus expectation of x whole square?
Okay, got it. Got it.
Got it? Now you try to solve it and tell me these are my answers. See, these type of questions will be coming in the question paper. So you guys need to know. You should be well aware about, very well aware about the formulas and everything. Mostly it is like concept ways. If you know the concept, if you know the formulas, it's very easy.
Got it, ma'am.
So everybody is getting this 102, sure? I'm just asking because only one person told me 102. I don't know if it's 102 or any other number. So everybody is getting 102?
Yes, ma'am.
Okay. And what about expectation of y square?
404.
40? 401?
404.
404? Okay. Everybody is getting this answer. Now can you tell me like variance of xy? Just put the values. What is this value?
1208.
Yeah, I need everyone to answer this. Everybody is getting this answer? 1208. Three, two. Only 5 people have solved it. 6. You guys still solve it?
Ma'am, could you
Hmm?
please explain again? I did not understand.
What? Which one?
That variance of xy from the beginning itself, expectation of x square and y square minus expectation of xy whole square.
Hmm.
We did not find that expectation of xy whole square.
Expectation. Okay. So expectation of just we are considering expectation of x, right? It is basically what? Expectation of x into expectation of y.
Oh, ma'am.
Yeah.
Yes, yes,
If we have this value, I just have to square it, right?
yes.
Yeah.
Ma'am,
Hmm.
ma'am, almost getting the answer 1207. Is it okay?
I think exact 1208 is because we have options, right?
Yes, ma'am, it's the exact answer, ma'am.
Yeah,
Coming
120.
direct, noting points also. It's the
Yeah.
exact 1208.
1208.
Okay, ma'am. I maybe calculator I points given, sir. Okay.
Shall we proceed to the next question or should I wait for more people?
Yes, ma'am.
We can
Please.
proceed.
Okay. Now, next question is, yeah. Suppose that a random variable x denotes the number of items produced in a factory during a week with mean 50 and variance 25. Using Markov's inequality, find a bound on the probability that this week's production will exceed 74. Solve it and tell me the answer.
Done, ma'am.
You are done?
Yes, ma'am.
Okay, let's wait for the others. What is the correct answer?
C.
D. Everyone is getting C option.
Ma'am, please.
Ma'am, I am getting B, the option.
B. Okay.
D, not B.
Okay,
Fourth one.
D,
C, ma'am.
B, and D. Anything else?
I will go with C.
C. Okay. So majority of them are with C and one person is with D, correct?
D here. I mean, I see that the answer is C, but I'm not sure how you got that.
Okay. Okay.
Let me
Okay, let's
attempt.
solve it. Huh?
Shall I try to?
No, the first person who told me that he solved the question, right? He will be explaining it.
Okay.
Gurpreet, I don't know. What is his name?
Yes, ma'am.
Yeah, can you just explain me how did you solve it?
Ma'am, it's direct. Just putting in the formula. Like mean
Yeah,
is given, constant is given. They just put in the formula.
Yeah, what is the formula?
X is greater than equal to C, less than equal to mu by C.
Okay, then
Then here mu is given 50,
mu is given 50.
and it is written that it is exceed from 74. So we take 75.
So it will be x greater than equal to 75. So this will be 50 divided by 75, correct?
75. Yes, ma'am. 2 by 3.
Yeah, so this will be 2 by 3. Now you got the point? Those who were saying D option,
Yes, ma'am. Got it. I got it.
got it?
Yeah.
Believe you got it?
But wouldn't D also be right because it's 74? So if you were to divide 50 by
Exceed 74.
Exceed 74, so we should take 75.
It's the same question as it's given in the
It is
practice
greater than 74, not equal to 74.
graded assignment.
Okay. All right. Okay. Thank you.
Yeah. Okay, let's move on to the second part. Using Chebyshev's inequality, find a lower bound on the probability that this week's production will be between 40 and 60. Solve this and let me know the answer.
Ma'am, can I tell answer or should I wait?
What is the answer?
0.75. 3 by 4, 0.75.
Yes, ma'am. Done. 0.75.
0.75. One person is getting 0.25. Priyanshi, right? You there?
What is the value of K you are getting? Is it 2 by 5?
2.
2. 10 by 5.
2 by 5. Okay.
Ma'am, is it 0.75?
Yes, 0.75. Should I wait or should I solve it?
Let's solve it.
Okay. So what is the Chebyshev's inequality? Probability that my mod of x minus mu is greater than equal to k sigma is less than equal to 1 by k square, correct?
Yes, ma'am.
And there is one other form. It is mu minus k sigma, mu plus k sigma greater than equal to 1 minus 1 by k square, correct?
Yes.
Yes, ma'am.
Okay. Now, according to the question, what is it given? Can you tell me the probability? Like, what is it given, the equation?
It is between 40 and 60.
Mu given, ma'am. Standard deviation given, ma'am. Range given, ma'am. And we can find from K and just put in the formula.
So, no, I'm just asking what, according to the question, the equation is given. It is given that my x is between 40 and 60, correct? Yes or no?
Yes.
And I need to find out the lower bound. So lower bound in the sense I need to find out this value, correct?
Yes.
Yeah. Okay. Now, if you just equate this thing with this thing, so I see that my mu minus k sigma is equals to 40.
Yes, ma'am.
Yeah. Okay. Now, according to the question, what is my mu? Mu is
50.
50. Mu is 50, and my sigma is
5.
25. 5.
5. Okay. So this is like, which is equal to 40. Now, k will be equal to what?
10 by 5 or 2.
By 5, which is 2. So everybody is getting k as 2.
Yes, ma'am.
Now, if I got k as 2, just put it in this equation. So this will be what? Less than equal to 1 minus 1 by 4. which is 1 minus 0.25, which is equal to 0.75. Fine.
How did you get the sigma of 5?
Sigma is my standard deviation, and my variance is given to be 25.
Sigma square is given as 25. I made the same mistake. I took the value as 25. I didn't.
Yeah, this is my sigma square, not sigma.
Okay.
Okay.
So the same question, if they ask the upper bound, here they have asked for the lower bound with the given parameters. Will that be? Is it meaningful to ask for an upper bound in this case?
No. In this case only, you can only ask the lower bound.
Okay.
If they're gonna ask you the upper bound, they will give you this case. Okay. Yeah. Okay. Shall we proceed to the next question then?
Just before we go there, so there are two forms of this Chebyshev's inequality, and we can expect the questions to toggle between these two. And is there any different dimensions that we can expect, like,
Dimensions in the sense, like in this method only, like you have to, like they will be giving you this intervals, then you have to calculate the lower bound, or they will be giving you something like k sigma, they will be giving you, then you have to calculate the k, and then you have to calculate this value. So some like similar way, in the similar way only you will be getting this question.
Not like inequality greater than only, like that will not come, right?
No, they won't give you the, they won't give directly, like they won't give you this direct equation. They will give you in statement. Then you have to figure out what is the equation that we are forming out, and then you have to calculate the bounds. Okay?
Okay.
Yeah. Shall we proceed now?
Yes, ma'am.
Okay. Now, the CDF of a random variable x is given to be this. What is the value of probability of -4 that x is going from -4 to 6?
Ma'am, B.
B. Other answers?
Option B.
B. Okay. Any other answers?
Option C.
Option C.
And this is all PYQs, no?
Yes.
Yes.
No, ma'am. Sorry. Option B. I maybe to take a wrong method. Option B.
Okay.
Just to confirm whether I'm approaching this correctly, should we need to take the integral of this function 1 minus e to the power of -4x with the limits as -4 to 6?
No.
Okay.
Is B?
Okay. So majority of them are getting B.
Yes, ma'am.
Okay. Should I solve it or should I wait?
No, we can proceed.
We can solve it. Okay. So we need to find out probability that my x is going from this. Okay, this is a CDF, right? CDF of a random variable, and this is a continuous thing. So I can say that f of 6 minus f of -4.
Oh, yeah.
Yes.
Okay. Now, okay. Now, what is my, so fx is given to be 1 minus e raised to the power minus 4x, correct? So what is my f of 6?
1 minus e raised to the power minus 4 into 6.
Everyone? 1 minus e raised to the power
Yes,
minus 4 into
24.
minus 4 into 6, correct?
Yes, ma'am.
Yes or no? Yeah? Okay. So, okay, so this will be 1 minus e raised to the power minus 24. Now, what is f of minus 4?
0.
0.
Why?
Because it's given that the other is 0. X is always greater than equal to 4. 0.
Correct. Yeah, correct. So basically, if you see here, my limit for x is going to be x is greater than equal to 0, all the positive values. But here my x is basically what? Minus 4, which is a negative value. So my f for minus 4 will be 0. So I will be left with this value. So what is f6? So my probability will be 1 minus e raised to the power minus 24. Got the point? Yes
Yes,
or
ma'am.
no? Yeah?
Yes, ma'am.
Sure. Shall we proceed to the next question then?
Excuse me, ma'am.
Yes.
Ma'am, how many questions left because of maths class? Can you tell me?
So in total, we have 14 questions. So 6 are done.
Okay, okay, ma'am.
Yeah. Okay.
These questions will be shared, right?
Yeah, yeah. It will be
In
shared.
it can be assessed in the calendar itself.
No, like I will be like it will be uploaded in the supplementary content by tomorrow, I guess. Yeah.
Okay, ma'am. Thank you.
Okay. Yeah. Okay then.
Ma'am, will the recording of this session be available?
Yeah, it's YouTube, huh? So you can
Ma'am,
watch the YouTube one.
ma'am, where PDF uploaded?
PDF will be uploaded tomorrow. By tomorrow, it will be uploaded in the supplementary content. Okay.
Okay, ma'am.
So the people who are here right now, so can you guys solve this question? Question number 7.
Ma'am, D, I think.
D.
Ma'am, D.
Okay. Is it done? 22% have told me the answer. What about others?
Wait 1 minute, ma'am.
Sorry?
Option D.
Wait a second, ma'am. Wait 1 minute only.
Okay.
D.
D. Okay.
Option D.
D. Okay. Now is it done? Everybody has done this question? Should we discuss? Yeah? Okay. So now we have a function here. We have fx as e raised to the power 1 minus ax, where x is going from 0 to infinite. Now, where find the value of a such that the function is a valid density function. So we know that it is a valid density function if my fx from 0 to infinite is equals to 1, correct?
Yes,
And my
ma'am.
fx is greater than equal to 0. It is obviously greater than equal to 0. I just need to find out this thing. Okay. Now, so this is 0 to infinite. E raised to the power 1 minus ax dx equals to 1. So we need to integrate this part. So everybody knows how to integrate this thing.
Yes, ma'am.
So if we make it easier, so this is like e raised to the power 1 into e raised to the power minus ax, right? Into dx equals to 1. So e will come out. So I'm left with from 0 to infinite, e raised to the power minus x minus ax into dx equals to 1. Now this thing is e raised to the power minus ax upon minus a from 0 to infinite, correct?
Yes, ma'am.
So e will be equal to, if I put infinite, this is basically 0, and if I put 0, this will be
1.
e raised to the power 1. This is 0, so
E
this
raised
is
to
e
power
raised to the power
0
1.
equal to 1. Yes,
1
ma'am.
by a, correct? Yes?
0 minus 1.
E raised to the power minus a into 0. This is e
Yes,
raised to
ma'am.
the
Yes, ma'am.
power minus
Yes.
0. So this is
Right.
basically what? 1 only, right?
1. Yes. Sorry, ma'am.
Ah.
1.
So this is equals to 1. Now this is e by a equals to 1. Now a equals to what? E. Fine. Now is it clear? Yes, so no. Shall I move forward?
Can we take it as e raised to 1 by 1 minus a into e raised to 1 minus ax as integral?
Yeah, sorry, once again, what?
Can we take directly like 1 by integral of e raised to 1 minus ax as 1 by 1 minus a into e raised to 1 minus ax? No. 1 by 1 minus a into
1 by 1 minus
a into e raised to 1 minus ax.
How?
Ma'am, in integration,
My
our
x is only getting multiplied by a, not the whole term, na?
Okay.
Okay.
ma'am, in denominator you write minus a, right?
Ah.
Where is gone minus a?
So this is what? So if I write this thing, it will be e raised to the power minus a into infinite upon minus a minus of e raised to the power minus a of 0 upon minus a, correct?
Yes, ma'am.
Minus plus.
Okay, you take it this way. Okay, ma'am.
Yeah.
I take it other way. Okay, ma'am. Okay, ma'am.
Okay. Is it fine? Shall I proceed to the next question? Yes or no?
So minus a infinity, it will be 0.
Yes.
A, because
Ma'am, in integration, there is a upper limit minus lower limit, na?
So infinite upper limit minus lower limit.
Okay, okay.
Fine. Shall I proceed further?
Yes, ma'am.
Okay. What about others? You guys have doubt? Only one or two person is saying something.
And the person who speak, they are gone for maths, I think. That's why.
Okay. So the person who are not speaking, like they never spoke, can they speak now? What's the issue? Okay, then. Okay, so
We can go on, ma'am, with the other questions.
yeah, but like if I'm asking you something, I need the answer because
So, ma'am,
I need to know, right?
I just stepped out. There was somebody at my door, and I lost the track. So I'm going to rewatch this exercise. That's my personal thing, but not sure about the others.
Yeah, no, it's fine. I just need a interaction, right? I need to know if you are done with the question, if you're okay with the question, then only I can proceed further, right? Otherwise, there is no point.
Sure, ma'am, sure.
Yeah. Okay. So find the value of k, enter the answer, correct to 2 decimal places.
One 1.25, ma'am.
Ma'am, please wait.
Okay, I don't remember the answer right now. Let's wait for the other people.
Yes, ma'am. 1.25.
1.25. Okay. What about others?
Ma'am, this type of hints also come in exam, na? Or we
Yes.
get a formula sheet?
The what?
Or we get a formula sheet.
Formula for what?
You said no, ma'am, we get a formula sheet for this differentiation and integration formula.
Yeah, they will just give you the basic what do you call that? How to solve an integration, like integration of x raised to the power n. What is the integration of this? This is basically xn plus 1 upon n plus 1. Na? They will give you like this, like the basic thing. Okay.
Okay, ma'am. Okay.
If any complicated thing is there and the complicated integration part is like in this question, they have given you the hint, right? So in this way, they can give you the hint if it requires.
Ma'am, what is the weightage? It's a 40 marks, na? And how many questions we accept?
So 6 is 12. Maximum 16, 16, 17. It's like 2, 10, 16, 17, 18 maximum.
Okay, ma'am. Okay.
Shall we discuss on the approach of this, ma'am?
Yeah, sure. Which is basically we have to integrate it, right? So we have been given fx and we need to find out the value of k. So we know that the whole integration like of fx is basically what equal to 1. So I can take it as from 0 to 4 k upon 1 plus x whole square dx equals to 1, correct? Now this thing is k, I will just take it out, 0 to 4 1 upon 1 plus x whole square dx equals to 1. Now they are stating, so they have given this thing, right? So I can write it as k integration of this is minus 1 upon, what is my b? B is 1 and a is also 1. So this is 1 plus x from 0 to 4. This part is clear?
Yeah.
See.
Yeah.
Sure?
We're
Yeah,
clear.
so here a is 1 and b is also 1. So we have this thing. So just put the values. So k is, if it's 4, so 1 by 5 minus of 1 by 2, correct? No, 1. So it should be minus 1. Fine. So now this will be 1 plus minus 1 by 5 equals to 1. So if you solve this, you will get 4 by 5 equals to 1. So this is k equals to 5 by 4, which is
Can you
equals
explain?
to
Okay. Can you explain the
1.25.
A and B part, ma'am?
Okay, so they have given you the hint that
Correct.
integration of 1 plus 1 upon a plus bx whole square is equal to minus 1 upon b a plus bx, correct? Now this same here, 1 upon 1 plus x whole square. So in this, if you just equate this, so my a is 1 and my b is 1. What is a? A is this
Yes,
constant term,
constant, ma'am.
and b is the constant term with x, right? Which is 1. Got the point?
Yes, ma'am.
Yeah, that's it. Is the question clear? Shall I proceed?
Ma'am, could you please explain that one, which is you take first k common and minus 1 by 1 plus x, integrate from 0 to 4. And that one, I just don't understand. Can you explain that one?
This one?
Yes, ma'am.
In the hint, they have given you this thing, na?
Ma'am, can we do directly also now by taking this numerator and do direct integration?
Direct integration, how?
Like 1 plus x square we take in numerator minus 2 raised to power minus 2, and after this we integrate, that minus 2 will come become minus 1 upon minus 1, and it become minus 1 plus x.
1 plus x. You can do that. But in this case, we have the in that case, we did that, like in this case, we don't have the constant term, na? So if we have any constant term or something, we have to deal with that as well. It's 1 plus x. So we have to deal with this thing also.
Ma'am, which constant term?
It's a plus bx, na? So we have to solve we have to integrate this whole value. It is
Ma'am,
not
it's
a
given
plus
the
b
hint, na,
whole
but if
x.
you don't take hint, then
So that is what. So you need to solve this thing. You are solving according to this, right?
but in my college and all, they taught me like this, so I don't know about that.
3x whole square. So let's suppose if it is like 2 plus 3x whole square, then how will you solve it? You will just write it as minus 1 upon 2 plus 3x, correct?
Then I solve the bracket also.
Yeah, you will solve the bracket as well, na?
Yes, ma'am. Minus 3
Yeah,
it
that
will
is
come.
what. That is what I'm asking.
Okay. Oh, ma'am, you are saying this. Okay, I understand. Okay.
Then you have to solve the bracket as well. Okay, so I was saying, what I was saying. Okay, so she has a doubt at this, right? You have a doubt in this?
Yes.
Okay. So we have to integrate 1 upon 1 plus x whole square, correct? And we have this is the hint that we have been given. So can you just equate these both of the left hand side? And can you tell me if my a is equals to 1 and b equals to 1?
What did you say?
My a
Can
plus bx is equal to 1 plus x. Now, can you tell me what is a and what is b?
So, ma'am, from this equation only you got this a equals to 1 and b equals to 1.
Correct. Yes.
Yes, ma'am.
Okay, so a is 1 and b is 1. Now we know that my value of a is 1 and b is 1. I can put in this equation.
Yes.
Yes,
Okay.
ma'am. Can we move to the next question, ma'am?
Yeah. Suppose x is a binomial n comma 1 by 2. Find the value of n for which 1 by 30 into this is the equation. Now solve it and let me know.
Ma'am, B.
B. What about others? Is the question done?
No, ma'am.
Okay.
No, ma'am, not know what to approach here.
Okay.
Ma'am, please solve.
Do I have to solve or should I wait for others to solve it? Should I?
Ma'am, please give us 2 minutes.
Yeah, sure.
Done, ma'am. Can we move to next question?
Is it done for everyone?
Done, ma'am.
Okay. So let's discuss it.
Yes.
So this is given 1 by 30 into probability of x equals to 3. What is probability of x equal to 3?
Uh, 1 by 30 NC3 1 by 2n.
1 by 2 n minus 3, correct? And what is probability of x equals to 2? It is basically 1 by
NC2
NC2 1 by 2
1 by
raised to the
2
power
n
2
minus
1
1
by
by
2 n minus 2. So you just have to equate this value.
Ma'am, the success is 1 by 2, right, ma'am?
Yeah, correct. So this will get cancelled. NC3 is basically n factorial divided by 3 factorial n minus 3 factorial. N factorial divided by 2 factorial n minus 2 factorial. This is 1 by 30. N will get cancelled. Okay, so you are left with this. So if you solve this, my n should be 92. Should I solve it or is it fine?
It's fine, ma'am.
It's fine, right? Shall I proceed now? Okay, using the Chebyshev's inequality, find a lower bound for probability of this, where mu and sigma square and mean and variance of x. Enter the answer correct to 2 decimal place. Yeah, correct.
Ma'am, can you scroll a little bit up? Sorry, down and down. That question I'm not able to see. Actually, my screen. 2 decimal.
0.75. Is it correct, ma'am?
Yeah, it's correct.
Ma'am, 0.75.
Correct.
Can I see the values, ma'am? Because I can't seem to. Oh, okay. It's for the same thing.
Is it done?
Yes, ma'am.
So how did you guys solve this question?
Take k equal to and then find lower bound 1 minus 1 by k square, where k equal to.
What is k?
K equal 2.
K equals to 2. How did you guys find out? It is basically this. I can write this equation
Lower
as
bound formula.
mu minus 2 sigma and mu plus 2 sigma, correct? Okay. So this is basically mod of x minus mu greater than equal to 2 sigma. And this will be greater than equal to 1 upon 1 by k square. Now 2 sigma is basically what my k is. Right? Yes or no? So what is my k? K will be 2 into sigma. What is sigma?
Sigma is not given.
Sigma is not given. So you have to calculate it. So my sigma square is coming out to be NPQ. N is my 92. So sigma square, that is 92 into P is 1 by 2 into 1 by 2. If you solve this, what is the value that you are getting of sigma square? Yes, sigma square is coming out to be 23. So now 1 minus 1 by k square will be equal to 1 minus 1 by, what is it? 2 sigma whole square, which is 1 upon 1 minus 4 into 23. If you have to solve this value, you should get 0.75. Is the question clear?
Yes, ma'am.
If we
Yes,
take the value as 2 and 2, then also we will get 0.75, right?
Sorry, once again.
1 minus 1 by 4 is also, we will get like 0.75 without finding the standard deviations.
Ma'am, here
What
the
happens
value
is that
of
this
A
should
is
be
2 sigma.
Yeah, correct. This
Definitely
was
we can.
1/4. Yeah, I forgot.
In
Yeah.
case 2.
Hmm. Here K is 2. You just have to put this value. Correct. Yeah. Sigma square. Okay. Hmm. Okay, shall I proceed now?
Ma'am, one quick question. What is mu here?
Mu, it should be NP, no?
Okay, okay.
And my sigma square is NPQ. So basically, this is what my K sigma is. So if we just equate it, my K is equals to 2, right? So we have the value of 2. We just have to equate it. Yeah.
All right, all right. Thank you, ma'am.
Yeah. I just confused it with the other inequality. Yeah. Okay.
Sure. Thank you.
Excuse me,
Now,
ma'am.
hmm?
I'm actually in max session. There is no instructor. By any chance, do you know whether the class is cancelled or it will be held? Do you have any contact?
Maths, is it instructor session or TA session?
Today's instructor session, ma'am.
Instructor session.
Do you know Maths 1, right? Or Maths 2?
Max 2.
Is it Vishal, sir? Like,
Mm.
so you didn't get any information regarding that?
No, ma'am. Didn't get any information.
Okay, let me just.
Normally we receive mail, but this time no mail. Okay.
Okay, I'll just confirm it with someone. Till then, can you just solve this question?
Sure.
I'm 4.
Just put it in the discourse or anything else because they are not picking up the call. So I'm not sure.
Okay, ma'am. Thank you.
Have you got the
Then,
answer at 4?
Yeah, got 4.
Yes.
Got 4? You just have to integrate it. Simple thing, correct? Now, find the probability.
Ma'am, can you show the question expression again?
And can you scroll down? And 0.69.
0.69.
Yes, ma'am.
Ma'am, please wait.
And what is the answer?
0.69.
Okay, ma'am.
Is it done?
Yes, ma'am.
What about others?
Getting wrong answer, ma'am.
Done, ma'am.
Getting wrong answer. So my k is actually 4. So we need to calculate from 1 by 4 to 3 by 4, correct? So what is the equation? Kx 1 minus x square. Kx 1 minus x square, correct? Now I can write this as 4 is common. 1 by 4, 3 by 4, x minus x cube dx. Now I can separate it out. So it is basically I'm integrating 1 by 4 to 3 by 4 x dx minus 1 by 4, 3 by 4 x cube dx. Now can you solve this equation?
Yes, ma'am.
Yeah.
I just directly put it in the expression. That is my mistake.
Ma'am, is the answer 0.17?
No.
0.69, ma'am.
Yeah. So if you solve this equation, you will get 0.69 as the answer. Fine. Shall I proceed now or should I wait?
Yes, ma'am.
Okay. Now, the PDF of a random variable x is given. Find the value of a and find the CDF of x. And you need to find out the value of this.
Done, ma'am.
What about others?
First part is over, ma'am.
First
I'm
part is over.
getting a equal minus 3.
Ma'am, what's the lower
I
limit?
think
Ma'am?
My lower limit is 0, right?
Upper limit is infinity.
Correct.
Ma'am, is the a is constant or like a log a like that? Oh.
A is a constant.
can you scroll down? Third part. Yes, ma'am. Done.
Done. What about others? Still solving?
Ma'am, in sixth, we can use B minus A formula. FB minus FA.
Correct.
Okay.
Ma'am, can you explain second question?
You need to find out fx. We know that my fx is basically integration of minus infinite to infinite of the PDF, correct? So now here I have the value of fx. So how will I calculate the capital Fx? It is basically differentiation of Sorry. Yeah. So we have fx. So yeah, we have to calculate the CDF. CDF is basically integration of minus infinite to x, right? Dx. This is my CDF.
Yes, ma'am.
Yeah. CDF is basically probability that x is less than capital small x, right? So I need to just integrate from 0 to x, not minus infinite to. Okay. Just solve this and let me know if you are getting answer B. Let's complete it now. It's already 8:39.
A third question is the answer B, ma'am.
Third question is B. Yeah. So all of your answers for first, second, and third, your answers are correct. Okay. What about others?
No, ma'am, not getting the correct answer. Please discuss this question.
Which
Here,
one?
e की power 3t minus 3t we take as a u, na? And after that, it converted into du, right?
Yeah.
Ma'am, here there's a power, na? E की power minus 3t.
Hmm.
We can take it as a u. We can
Why
let
you are
u.
taking it as a U? You can just solve it clearly, na? Okay. So you need to solve me the first one also. You are getting 3. The one who asked me Sakshi, right?
No, ma'am, not getting. I am integrating, but I have no idea where I am going wrong. I have done such question too.
So my integration 0 to infinite a e raised to the power minus 3x dx equals to a e raised to the power minus 3x upon minus 3 0 to infinite. This will be a raised to the power 1 by 3. This will be equal to 1. A is coming out to be 3. Okay. Now fx is, they will be integrating from 0 to infinite 3 e raised to the power minus 3x dx. This will be 3 into e raised to the power minus 3x upon minus 3, 0 to 0 to x. Okay. Now this will be equal to 3 will get cancelled. So I will be left out with e raised to the power minus 3x minus 1. Right? What is the answer?
Ma'am, the second part, can you do it again? The for the fx?
Fx is 0 to x, right? This is the CDF. 3 e
Yes.
raised to the power minus 3x. 3 will get common out, so I will integrate this part. So this is basically e raised to the power minus 3x upon minus 3, 0 to x. So just put the values of x and 0. So you will get this value.
Oh, yes, ma'am.
Yeah. And now we need to calculate probability that my x is going from minus 4 to 6. This is actually f6. f4 will not exist because it is 0. My x is positive. So this is basically 1 minus e raised to the power minus 18. Fine. Is this question
Yes,
clear?
ma'am. Yes, ma'am, clear.
Clear? Okay. Let's proceed to the next question then. A package delivery time is uniformly distributed over the interval AB. It is known that the probability that the delivery takes less than 5 hours is equal to the probability. Okay, let's do one thing. I'll just share this. Okay, there are just Chabishas and Nikalri, same questions. 3 more questions are there. You guys try to solve it, and in the mock discussion, you can ask the question. Yeah?
Ma'am?
Huh?
Ma'am, if you have time, no problem. We are waiting because maths 2 class, I think it is probably cancelled. If you can continue, then please.
Okay. Okay, yeah. Then so try to solve this question then.
Because it is only 4 to 5 question left, it will be easier. And
3 questions are there.
yes, ma'am, we can wait for 3 questions. 15
Okay, so
minutes more.
yeah, try to do it, please.
Done, ma'am.
You're getting this answer?
Yes, ma'am. 0.57. Yes, ma'am.
What about others? Are you guys solving or not? Because I'm
Yes,
not
ma'am.
getting any response other than 1 or 2%. So that's why I'm just asking.
We are trying to solve, ma'am.
Yeah. Okay. Then that's good. Is it done?
First part, ma'am.
First part is done.
Yes, ma'am.
Oh. What about the second part?
Not getting
Done, ma'am.
the
Sorry. Sorry, I couldn't get you. See, I'll just give you the hint.
not able to solve, ma'am. This
Ma'am,
question
can
not
you
able to solve.
can you explain the first part, ma'am?
First part. Okay. The first part is we need to calculate the value of a plus b, and t is following a uniform distribution with a comma b. It is known that the probability that the delivery takes less than 5 hours is equal to the probability that it will take more than 11 hours. Okay. So t is less than 5. It is basically what? My CDF, and CDF of a uniform distribution is basically x minus a upon b minus a.
Yes, ma'am.
Correct. So this is basically what? My f5, and I can write this as 1 minus probability of t less than equal to 11. So I can write this as 1 minus f of 11. So f of 5 is basically 5 minus a upon b minus a equals to 1 minus 11 minus a upon b minus a, right? So if you solve this value, you will get b minus a plus a. So we will get cancelled 5 plus 11, 16 b plus a. Okay? Is it fine? Is this
Is that
part
the
clear?
expectation, ma'am? X minus a by b minus a, right?
This is CDF. CDF.
Ma'am, how did you know from the question it's a CDF?
Not from the question. They have said that the probability that the delivery takes less than 5. So this is probability that t is less than 5 is equal to the probability that it takes more than 11. So it is probability that t is greater than 11. What is my fx? Fx is basically probability that my x is less than equal to some value.
Yes.
Yes, ma'am.
Yes. Okay.
Oh, yeah.
So this is probability of t less than 5. It is basically same only, right? So this is f of 5.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay. So can you do the second part? Second part is basically they are asking 5 to 11, given that my t is greater than 7. So this can be written as probability that t is going from 11 and t is greater than 7 divided by probability that t is 7. Now, what is the common point in this?
7 to 11.
So this will be probability that my t is going from 7 to 11. Everybody agrees with this?
Yes, ma'am.
Yeah. Now, can you find out these four values?
Yes, ma'am.
Yeah. Sure. Everyone? I mean, everyone.
Yes, ma'am.
Yes,
Yeah?
ma'am.
Okay. So this question is done, or should I wait for the answers?
Ma'am, just wait.
Done,
At
ma'am.
first, not able to do. Please wait.
Okay, sure. Till then, those who have done, can you just solve this question? Just solve this question till then.
Ma'am, what is the answer? Can you please tell?
Done, ma'am.
0.16.
0.57.
Ma'am, can you scroll down for the second part?
Okay, got it.
Sakshi, are you done?
Yes, ma'am.
Yes,
I will.
ma'am. C part. Done, ma'am.
You're done with the both of the parts? You're getting 0.5 and C option?
Yes, ma'am. 0.80. I get,
Zero.
which is I think C.
Okay.
I guess.
So what about others? Are you getting these answers? Just let me know if it's done.
Yes, ma'am.
This question is done?
Yes, ma'am. Almost. First question is done.
Okay. What about others? The first part is done?
I'm both done.
Yeah, yeah. Other than you?
Ma'am, first part done.
Okay. What about the second part? Still doing?
Doing, ma'am.
Okay. Just let me know when you are done.
Yeah, sure.
Yeah. Those who are not speaking, are you guys doing it or not? Can I get a thumbs up at least? Okay. Only 2, 3, 4. That's it? Yes. Only. There are 15 members here. And I got only 5 thumbs up.
Ma'am, after this, can you please solve the second part of the previous question?
Sorry?
Ma'am, after this question, could you please solve the second part of the question number 12?
Question number 12. Okay, you guys are still solving this question, right?
Yes, ma'am.
Okay, so till then I'll just solve this question. So probability that you need to find out. Basically, you need to find out f of 7, f of 11 minus f of 7, correct? And this I can write it as 1 minus f of 7, correct?
Yes, ma'am.
Yeah. So now what is f of 11? F of 11 is basically my 11 minus a upon b minus a. So it is given that my b is 4. So what is a?
Raise to
What is a?
14 if
B is 4, right? So if my B is 14, sorry, B is 14. So what is my A?
2.
A is 2. So just solve this 11 minus 2 upon 14 minus 2. This is 9 by 12. Now f of 7 is 7 minus 2 divided by 12, which is 5 by 12. So we have these values, just put these values. So this is like 9 by 12 minus 5 by 12 divided by 5 by 12. So 12 will get cancelled, 4 by 5. And 4 by 5 is basically 0.8, correct? Is this the answer? Yeah. 9 minus 5, 4. Oh, sorry. So this is 1 minus 5 by 12, right? So this is basically 9, 12 minus
4 by 7.
4 by 7. So this value is coming out to be
0.59. 57.
57. Yeah.
Yes.
What? Fine. Utkarsh, is it okay?
Yes, ma'am. I didn't see that B's value was given. Okay. Thank you.
Is this question clear? Everybody is getting these answers?
Yes, ma'am.
Shall I proceed now?
Yes, ma'am.
Yeah, other than Gur. I don't know. What's your name? Gur.
Gurkirat Singh, ma'am.
Gurkeeper. Okay, sure. Okay, so other than him, can I proceed? Can I get a thumbs up from everyone else? Okay, now this is the last question.
The second part, can you solve?
Okay, let them just
Yeah, sure, ma'am.
yeah, then I'll just go with that. This is the last question. You will solve it and let me know.
Done, ma'am.
Done. What about others?
Second part C. Right.
Okay. One person had a doubt in the second part, right?
Yes, ma'am.
Okay. So the question is, suppose that a factory accumulated let X be the number of defective gases, the mean and variance is given using final lower bound. Okay. So we need to find out probability that my X is going from 30 to 70, correct? And this is equal to what? Mu minus K sigma. So my mu according to the question is given to be 50.
50
And
sigma
variance is
is
given to be 81. So
81,
sigma is
9.
9. Okay.
Yes.
So my mu is 50 minus K into 9 will be equal to
Is
30.
20 by 9.
20 by 9 is my K. So I know the value of K. So 1 minus 1 by K square is basically 1 minus 1 by 400 divided by this one, right? So this is
391 by 400.
319 upon 400. Is that fine?
Yes, ma'am.
Oh. Is the question done?
Yes, ma'am.
What about others?
I'm facing difficulty in solving this. I don't know where to start.
Okay. So they are asking probability of x1 greater than 2 is t by 9, right? So, okay. So I can write this as 1 minus probability that my x1 is less than equal to 2.
Yes,
Can we
ma'am.
find out this value? So this is basically, I will be summing it from x is going from 1 to 2, right? So,
Yes, ma'am.
so this is basically 1, 1, 2 by 3, 2 by 3, 1 by 3, x is 1, so this will be 0,
2 by 3,
plus 2
1 by
by
3.
3, k by 3, right?
Yes, ma'am.
So this is 1 minus, this is 2 by 3 plus 2k by 9 equals to 2 by 9. Now can you solve this and tell me the value of t? You need to find out the value of t, no? Is it clear, Utkarsh?
From this third statement, how did this come to be?
This one? Okay.
Yes.
So x1 is less than equal to 2, right? So what I would be doing, my x is falling, the PDF of x is basically what? 2 by 3, 1 by 3, k minus 1, where k is going from 1, 2, 3 in infinity, correct? Now I need to find out probability that x is less than equal to 2. Basically, this is probability that my x is equals to 1 plus probability that my x is equals to 2. Yes?
Understood, ma'am. Got it. Thank you.
Understood? Yeah.
Yes, ma'am.
So can I get the value of t now?
Now here we take k value 1, na?
K will be,
T is 1, ma'am.
yeah, k will be 1. In this case, it will be 2, na? This
T
case it
will
is
be
1
1.
and this is 2.
Yes, ma'am.
The first part is done. Then the second part is they are asking z of maximum of x1, x2 and x3. And probability I need to find out is z is less than equal to 2. So
No, it's
basically
a
this is
power, na? 1 by 3 power k minus 1, na? You
yes.
put it in numerator. 1
Oh,
by 3
opposite
power
k.
k minus 1. Yes, ma'am.
So this is 1 by 3 and this is also 1 by 3. Okay. And the next thing is they are asking about x1, x2, x3 maximum. It should be less than equal to 2. So basically I can write this as probability that my x1 is less than 2, x2 is also less than equal to 2 and x3 is less than equal to 2. And as they are independent, I can say that probability that my x is less than equal to 2 raised to the power 3. And what is this value?
8 by 9.
8 by 9. So 8 by 9 raised to the power 3. Is it 8 by 9?
Yes, ma'am.
Okay. Now is it fine? Both of the question, both of the parts, or still you have doubts?
Ma'am, all question finish?
Yeah. Yeah, it is finished.
Please share this PDF also.
Yeah, I'll share the PDF. Is this question done by everyone?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Okay. So how was the question?
Ma'am, moderate.
Totally fine,
Moderate?
ma'am. Great questions.
Great questions. What about others? See, these type of questions will be coming in the exam. So now you know your limit, like where you are. Okay. So just practice more. Okay.
Ma'am, when will there's a revision session of 1 and 2?
1 and 2 is done.
Done?
Yes.
Okay.
And ma'am, should we practice any previous year question, or the from week 1 to week 4, what are the activity question, practice assignment, graded assignment? Is that alone enough?
See, just do all the activity questions, the practice assignment and graded assignment question. Okay. So
Okay,
the
ma'am.
thing is that if you're solving it, you should remember the concept that you're using. The main thing is if you have done all of these questions, they're just basically doing they're using the concept, right?
Yes.
If you remember the formula, you know the concept, you just have to put it. That's it. Nothing else is there. Correct?
Okay. Oh, yes, ma'am.
Yeah. Okay then. So that's it.
And level of the question, it will be based on it will be similar to mock quizzes there, right?
Yeah, the mock quizzes or the questions that we have done today, like that. Okay.
Singing.
Okay, ma'am. Okay.
Okay.
Please
Then.
share the today's
Thank you.
PDF.
Thank you.
Yeah, by tomorrow it will be there in the supplementary content. Okay.
Okay, ma'am.
Yeah.
Thank you.
That's it.
Ma'am, did you by any
then.
chance take? Ma'am, I have a question. Hello.
Yes.
Am I there? Yes, ma'am. Did you also
Yeah,
take
I'm
the
there.
revision session for week 1 and 2?
No, I did not take it, but some other instructor. I don't remember. But it was done
Are the
by.
PDF for that session also available in the supplementary content?
I guess it should be there in the supplementary content.
Okay, ma'am.
Just
Thank you
check
for
it
the
once.
session.
Yeah. Okay then.
This
Bye
PDF,
everyone.
where we will get this?
Thank you.
Which one? Supplementary content?
This PDF, ma'am.
Supplementary content. It will be uploaded by tomorrow.
Okay,
Okay.
ma'am.
Yeah.
Thank you.
Okay then. Bye everyone. All the best for the exam. Okay. Just the main thing is you just have to read the question more carefully. Okay. And do more practice and have a speed. Okay.
Thank you for your time,
Okay,
ma'am.
everyone.
Thank you. Thank you, ma'am.
Yeah. Okay, everyone. Bye. Good night.
Good night.